So we finished off the last day by introducing navigation or routing to our React app. And we know that that feature is actually performed by a completely different third-party library. In our case, we use the React Router library. There are others, but it's the definitely the most popular one. And so we're down here. By the way, if you have already downloaded the archive from Monday's lecture or after Monday's lecture, you might just download it again. I had to make some very small changes to it. Really, the changes only relate to upgrading from React 17 to 18, which has no impact on routing as it turns out, but just for consistency, because I want to use React 18 right across the module. Anyway, so we're working our way through these slides here. And technically the way we do it is we need to create a component, and we put what is called the routing configuration for your app into that component. And the routing configuration looks like that syntax that you see on the top right there, which I talked about the last day. And what I also mentioned the last day was the way things work is every time the browser's URL address bar changes, the React Router library intercepts that event. Ordinarily, when the browser's URL address changes, the browser actually makes a HTTP request to whatever new URL is contained in the address bar. But when you're running a React app inside a browser, the routing library, React Router in our case, it actually intercepts that event and handles the change of URL address. And the way it does it is it essentially consults these root entries in your routing configuration to decide which component should it mount onto the DOM, replacing the component that's currently there. So it's doing kind of a swap. We put our routing configuration into a component. In my case, I've just called it the app component. And that is the component that you manually attach to the index.html page in your code. So strictly speaking, it's the component that contains your routing configuration. That is at the very top of your component hierarchy. I've mentioned a couple of times that every React app is comprised of a component hierarchy. Well, we now know that the component at the very top of that hierarchy is always the one that has the routing configuration. And everything else kind of flows downwards from that. So that's fine. That's routing configuration. And it really doesn't get any more complicated than what you're seeing there on that screen. Just more entries, that's all really. We also talked about if you want to have hyperlinks, then you should use the link component, which looks like the thing on the right there, fairly straightforward. Just has one prop called to. You specify the URL that you want to change the address bar to and all of that. So that's fine. Then we talked about essentially what are called parameterized URLs. The opposite of a parameterized URL is a static URL, which never changes. A parameterized URL, part of the URL is a variable essentially. And we have two examples there at the top of the screen. Invariably, the variable part 1, 2, 3, 1, 2 or 2, 2 there. Invariably, it's actually an ID for some kind of database entity. So it looks like it might be user ID here. In the case of our movies app, it might be a movie ID or an actor ID. That sort of notion. It doesn't have to be, but in most cases, it is some sort of identifier for some data entity that can be retrieved from either a web API or a database. And we want to display some information about that data entity. In this case, it would be users. In this case here, it would be the purchases made by a particular user. That's the notion of it. And the component that's mounted as a result of the browser's URL changing to a parameterized URL, that component that's mounted typically wants to access the particular variable value. And I showed you the last day how to do that. There was a hook that enabled us to do that. So that's where we left off. So I'm just going to skip over to the next aspect, which is called nested routing. Now, as it turns out, I don't use this in the Movies app. It's a nice feature, though. If I were to use it, I'd have to completely redesign the app. That's just by the way. But so I will just explain what nested routes are. They're quite a nice feature, but I don't use them, as I said. The idea here is that you've got a component and you want a child of that component to be dynamically determined based on some part of the browser's URL address. Okay. So for example, if we're sticking with our use case, if you can remember from the last days, this notion of a very primitive email client, when we had this inbox component, which probably would display a user's emails that they've received. We know what an inbox is in email terms. Now, let's supposing this is one of the root entries in my email client. It's a parameterized route, which we talked about the last day. So the user ID is part of the URL. So whenever the browser's URL changes to /users/some value, this inbox component is mounted. That's fine. But we're saying down here, if the URL has another bit tagged down at the end of it, in my case, I'm saying if it has /statistics tagged on to this part here, then I want the inbox component to be mounted, but I want the stats component to be mounted as a subordinate of it. Whereas if the URL looks like this, where it has /draft at the back end of the URL, then I want the inbox component and a draft component to be mounted. So draft and stats here, we would say is a child component of inbox. But which one is actually active or mounted at any time is determined from the URL, kind of the suffix part of the URL. How do I express that, or how do I achieve that in my routing configuration? And the answer is, this is how you do it. You simply can nest root entries inside other root entries. So this root entry is the root entry for the kind of base URL. And it says, okay, mount the inbox component. But this is saying if there is a stats bit, note this is a relative URL, whereas this is an absolute URL. So because it's relative, the React router interprets it to mean this part is tagged down to the end of this string here. So if the stats component, if the statistics appears at the end of the URL, then mount the stats component as well as the inbox. This is the drafts option. This option here is when neither statistics or drafts is at the end of the URL. In other words, it's just /user/user ID /nothing. If that's the case, then mount the filler component as a child of inbox. So these are, we would call these nested routes. And I'm just reminding you, make sure to use relative path names. If you use absolute path names here, that kind of messes things up, doesn't work. And the index case is kind of the default or fallback case. Now, the question then is, where within the inbox component should we kind of attach these child components? And that is expressed by a special component called the outlet component provided by the React Router library. So I think this is what the sample is. This is sample 4, I think, if I go back. Sample 4, yeah. So if we look at sample 4, now you know the drill from the last day. I want to change the top level index.js to the sample number. So I'll change it to sample 4. I've already started my development server. And just to illustrate, I've just got some hyperlinks. So if I click on this hyperlink, note the URL up here. It's just /inbox/user ID. And so what you're seeing on the screen here is rendered by the inbox component. But I can tell you that this part here is actually rendered by the filler component. Whereas if I click on this hyperlink, notice the URL now has the /statistics at the end, and the /statistics produces this part here, whereas the inbox produced this. And the third one then was drafts. Okay, so this bit here is produced by the drafts component. And if we look at the actual code, now, admittedly, I'm kind of picking up from the last day. So the hope is that what I did the last day is reasonably fresh in your memory. In the index.js for sample 4, there's nothing too interesting here. That's just my routing configuration. But here I do have my nested routes, which I've shown you on the PowerPoint slides. And so all I'm really interested in is the inbox component. The inbox component, which is here. And this is what the inbox component generates. So inbox page, you know, that's what we saw. Yeah, that's what we saw there, inbox page. Or yeah, message is just a local little component that I have here just for convenience. There's message, and it outputs messages from user whatever, which was that. Sorry, let's go into one of them. Let's go into this one. Messages from. And so the last part then comes from the nested route. But if we go back to my inbox component, you can see here I've got a component called outlet. And outlet you see on top there is actually imported from, here it is, imported from the React router. And what happens with the outlet component is that at a runtime, it is replaced by the nested routes component. My nested routes component were these two here, my stats component and my drafts component. The stats component, I think, which is the one that we are seeing on the browser at the moment. Yeah, because look, the URL ends in statistics. So it must be that this stuff here is coming from the stats component. And is that true? Yeah, that's what we're getting. If I just bump it up a little bit. That's what we're getting from this is what's being generated by the stats component. Okay, again, as before, you may need to go back to just clarify these in your own mind or ask a question if you have a question. That's nested routes. They're a nice feature, but as I've already said, I don't actually use them in the lab, but you may get an opportunity to use them in your assignment, maybe. The next feature is extended link, or an extended version of the link component. Remember, the link component is how we implement hyperlinks in our React app, where we want to navigate from one view to another view within the app. And we know that when the user clicks, as I kind of said probably too many times now, when the user clicks on a hyperlink, that changes the browser's URL, and the React router makes a routing decision, and it mounts a new component onto the DOM, replacing whatever component is at that particular position on the DOM. Now, what if the new component that it mounts, what if we want to pass some props to that component, some additional props? Well, the link component provides that facility for us, and I do use this in the lab as well. So the objective is to pass some additional data in a hyperlink, essentially pass them to the component that's mounted as a result of the routing decision that has been made. So this is sample 5 we've moved on to, and it's a made up sample really, but here's my home page with my inbox hyperlink. And here's the implementation of the hyperlink. And really it's just arbitrary stuff, but sorry, now I just need to, you know, let's suppose I've got some piece of data. Now I've just hard coded a piece of data here, like I've just got a variable with a string attached to it, but it could be easily just some data returned from a web API or whatever. It doesn't really matter. And I want to pass this as a prop to the component that's mounted as a result of the user clicking on this hyperlink. So here's my link component. Here's the top. Here's the link component. It has a top prop as before. Am I looking at the right one? Sorry, it's this one. This one here. Here's the this is for the home link on the left. And here's the link component. It has a top prop as before, but it also has this state prop, which is optional. You may or may not want to use it. We didn't use it up to now, but if you want to use it, the idea of the state prop is where you can pass data. And in my case, and you assign state an object, which is what I'm doing here. Okay, I'm just creating an object with one key value pair. So I'm passing this user profile string, as it turns out, to my component. Now, what component? Well, based on this routing entry in my routing configuration, if the URL is, it says here, if the URL is /inbox/1234, that's going to match this path. So the inbox component is going to be mounted. So that means I want to pass this user profile data to the inbox component. And the question is, how does it access that data? Well, how it does it is, if I, just take a step back, every time the browser's URL address changes, the React router creates a special object called the location object. And that object contains essentially kind of information about the new URL that has been entered into the browser's URL address bar, plus some additional information. It always creates this location object every time the browser's URL address bar changes. And what I'm showing you here on the left is the actual structure of that location object. Now, most of the properties of that object we don't ever use and we don't care about. We don't care about whatever the hash value is. We don't care about key. Path name obviously makes sense. Path name is going to be assigned whatever is what the actual URL is in the address bar. Search we don't care about. I think that would be relevant if the URL in the browser's address bar contains a query string, if you remember what query strings are. Here's the part we're interested in though right now. There's this state property within the location object, and you can see its structure is actually consistent with, if I go back to the previous slide, it's consistent with the structure that I've assigned to state here. So there is this location object. Can my inbox component access this location object? Yes, it can. How does it do it? It's nearly the same answer for all of these questions. There's a hook that is available to us, provided by the React Router library. Here I am using the hook. It's called the use location hook. What it returns is an object. It essentially returns this thing on the left here. And all I'm doing here is I'm using destructuring to dig down into the state part of the object and go further into the state property to dig out a key within the state object. That's really what I'm doing over here. It is destructuring. You can use destructuring to any degree of nesting that you want to. In my case, I've got 1 degree of nesting, as in this object is nested inside the location object. So the way you interpret this is find the state key within this object. And from that key, take the value, and the value will be an object, dig out the key called user profile within that nested object, declare a variable called user profile, and assign it the value assigned to that property, which in my case is going to be, this string over here. And then I can do whatever I want to with that value. So the use location hook is how you get at the data that was included in the hyperlink. There's a couple of steps there now, admittedly. That's sample 6. I don't really need to look at sample 6. You have the key parts of the code, which is what you're seeing on the screen here, and what's on the previous screen. So you can go back in your own time. You can actually get sample 6 running and make sure you understand it, because I do use the location object in the lab as well. So you need to be aware of what its role is. Right. Now, that sample 6, there are, I think, is it 8 or 9 routing samples? The remaining ones I will look at probably, well, definitely either next week or the week after, because we will need the remaining ones as well. They're a little bit more involved, and some of them reuse some of the features we've already looked at. So we're kind of building up slightly more complex routing coding, if you like. So that's for next week. Back to the website. And now I want to do a complete change of gear and talk about something called design patterns. And as usual, Zoom starts complaining. Let's see. Now, this topic, design patterns, it's not a topic related to web apps specifically. It is a general software engineering or software development topic. And the book cover that you're seeing there on the left was the first text published in this kind of area. So it kind of introduced us to the, as software engineers, it introduced us to this notion of design patterns. Now, the book goes back to 1995. I had to check this morning when it was actually published, which is probably before any of you were born. But there was a lot of software development happening back then as well, for a number of decades leading up to 1995. And what the authors of the book did was they embarked on looking at a number of software applications across a broad range of application areas, with the objective of trying to identify good design and bad design within those applications. Some of them are open source, some of them weren't, whatever they could get access to. So their objective was to identify within applications code that was well structured and well designed. And those designs, which I guess they decided what was good and bad design, but they were very experienced engineers. So, and the book was extremely popular. So these designs that they saw in particular applications, they essentially abstracted the more general case of those designs, represented them usually diagrammatically using UML diagrams. I don't know if you've ever come across UML diagrams. They were very popular back around then, but they're just diagrams for representing software structure or software design. So they looked at specific a range of applications, and within those applications, areas of the application that they thought were well designed, they represented those designs diagrammatically and generalized the designs. So they came up with more general design structures and then published those designs in this textbook, and also explained the particular application areas for these designs. And they documented each design by giving it kind of a title or a label. And that labeling of the various designs became part of the kind of vocabulary of software engineers. And so each of these designs is what's called a design pattern. And I'm kind of defining what is a design pattern here. In software engineering, I'm saying a design pattern is a general repeatable solution to a commonly reoccurring problem in software development or software design. You know, a lot of software has been developed over the decades, and within various applications, there are parts of those applications that are implementing a solution to the same kind of problem that other software engineers are trying to solve in their applications. So there's a certain amount of repetition going on across the software development world. And rather than each software team coming up with their own design solution for a particular aspect of an application, why not base the design of that particular aspect of an application on a well understood design pattern, possibly from this book. And it also, this whole area of design patterns kind of facilitates a better understanding of software engineering between software engineers. And so over time, software engineers develop or build up knowledge of the various design patterns that were published in this textbook, and it becomes part of the vocabulary of software engineers. So if I say to you that to another software engineer, I used a particular design pattern in my implementation of a particular feature of my application, then by just saying that I used a particular design pattern and naming it, then the other software engineer has an understanding of the way I structured my code for that particular part of the application. That's kind of the idea. As well, you know, for these various patterns that are documented in this book, as well as describing the structure of the code in terms of its module breakdown and the interaction between the various modules, it also talked about when or where that pattern should be used and in what types of problems should it be used or applied to, and maybe what problems it shouldn't be applied to. So then as a software engineer, you're embarking on developing an application. There's a particular feature within the application that you need to implement. And the nature of that particular aspect of the application is similar to the nature of a particular design pattern's application area. And then you decide, let's use that actual design pattern. You may not copy it directly, you may adapt it a little bit for your particular use case, but the general structure is consistent with the pattern that has been documented in the book. And over time, other design patterns have been cataloged, and there is very good online catalogs for these design patterns that have evolved over the decades. That's the background. There are common reasons or objectives for all of these design patterns, and they're all about improving reusability of code within your application and between different applications that you might develop. Clearly, we know that reusability is a good thing. You know, we break our code up into modules. Whatever constitutes a module might be a class. If it's an object-oriented language that you're using, it might even be a function, if it's a language like JavaScript. And we'd like to be able to reuse modules if we need to within an application or across applications. Separation of concerns, the idea there, I'm sure it's a term you've heard of. Separation of concerns, the idea is that each module, or again, a module might be a class or a function, has only one responsibility or one concern. It's never a good idea for example, to have a class that is concerned with a number of aspects of the particular problem domain. You need to try and, if that arises, then you need to break that class up into a collection of smaller classes. So separation of concerns, and the reason we do that, of course, is to make it easier for other people to understand our code. So reusability and separation of concerns are high-level objectives for software engineers when they are developing any particular piece of code. And these objectives are consistent with the whole design patterns idea as well, because the design patterns that were documented by the authors of the book in the previous slide, you know, they were also trying to maximize reusability and improve separation of concerns in the actual pattern structure. Another objective when you're developing software is what's referred to as the DRY principle, or the DRY objective, where DRY stands for don't repeat yourself. DRY and reusability and separation of concerns, they're all kind of interlinked, and they're all kind of trying to achieve the same outcome, which is to have a set of, break up your software's architecture into a collection of modules, where as many of those modules as possible are reusable within the application or across applications. Each module has only one concern, and there is no repeating code between modules in an application design. Now, where's all this going? How do we achieve these things of reusability, good high reusability, good separation of concerns, minimum dryness, or maximum dryness, I suppose you would say? There are essentially two approaches that you can take as a software engineer. One is the inheritance approach, the other is the composition approach. You've heard of inheritance, you've come across inheritance when you were studying Java in first year, if you can remember, and perhaps in second year as well. With inheritance, if you remember, essentially what you're trying to do is you're trying to model the problem domain that you're developing your application for. You're trying to model it as a set of what are termed is-a-type relationships. That's how you're trying to view the problem domain that you're developing an application for. A very simple example of an is-a-type relationship is this kind of statement here. A car is an automobile. Now, if car and automobile were concepts in the problem domain that we were developing an application for, doesn't have to be a web application, and you were following this inheritance approach, then you would probably have an automobile class, and you would have a car class, and car would be subordinate to automobile. You know that from before, hopefully. So in terms of your classes, if we're talking about classes, you're going to have a number of inheritance hierarchies within your set of classes that make up your application. You will have multiple hierarchies, not just one inheritance hierarchy. An alternative approach is the composition approach. In the composition approach, I know now this is may sound kind of waffly, but it is a high level kind of topic that I'm talking about, but I'll boil it down to where does it come into play with developing React apps in a moment. In a composition view of the world, you're looking more for has-a type relationships. For example, a car has an engine. When you're modeling the world with these composition type relationships, and if we take this particular one as an example, then you're going to have a car class, you're going to have an engine class, and within the car class, it's going to have a property of type engine. So it's more you're composing things in this composition world. Okay, so they are opposing approaches. Inheritance and composition are kind of opposing ways or alternative ways of modeling your problem domain. React is more geared towards composition. And to come back to patterns, in the React world, there are a number of patterns that have emerged over time. And I'm listing the 3 most common patterns that you might come across when you read about React. I'll cover the first 2 because we use them in the lab. I probably won't cover the 3rd one just for time constraint reasons, but you can certainly read up on it yourself. I may decide to cover it maybe next week. I'll decide later on. So we're back to React, and we're back to talking about using design patterns in the implementation of our React code. Now, before I talk about those patterns, though, I just want to mention the concept of children. In the slide here, I'm talking about children just in the context of HTML. It turns out that HTML is very much geared towards composition as well. You can compose elements from other elements. So, for example, using the language of composition, I would say that this on the left, that this div is composed of a H2 element and a UL element. And the UL element is composed of LI elements. On the right, this div is composed of a paragraph element and an image element and a hyperlink element. So that's composition in the HTML world. The other term that we would use when we're describing this code is to say that the div element here has two children, sorry. So H2 and UL are children of div. On the right, the paragraph and the image and the hyperlink or the anchor tag are children of the div element. Now, this notion of children, though, actually is part of the React kind of idea as well. So the first pattern in those 3 patterns that I mentioned 2 slides back was the container pattern. And the statement is saying that all React components have a special children's prop. It's been there all along, we just haven't been using it up to now. And the sentence is saying that the children prop is there so that a consumer can pass components directly by nesting them in the JSX. So if you've got a React component and you've got a consumer is just another component that's using your React component. the consumer can pass to the React component. It can pass children to it by just nesting them within the React component's JSX. Let's see something tangible. I've got a component here called picture, and I've kept it as simple as I can. The picture has a div, it has an image nested within the div, and then it's invoking props.children, and whatever that expression returns is going to be inserted into this overall JSX. And children is a property of props, okay? So where does this children get its value from? On the right now, I'm showing you what I'm calling a consumer of the picture component on the left. And again, I've tried to keep it as simple as possible. So here's my consumer component, just call that our component. And it's using picture. And here's the picture opening tag. And here's the picture closing tag. So essentially, whatever JSX you put in here, that JSX is going to be bound to props.children. And that's what React will do for you. You don't have to do anything to achieve that. This children's prop is built into the React engine itself. So when the picture component renders, it's going to render an image within a div, it's going to render an image within a div, and it's going to render whatever JSX was over here, was specified by the consumer. So essentially, what we're achieving here now is decomposition. We're decomposing the internals of a picture, and the consumer can dictate what should be part of the internals of our picture component. And different consumers might have different requirements as to what they want to follow the image with, if you like. Here's some kind of abstract examples. Well, I suppose they're not abstract, they're very specific. Here I've got a consumer component, and it has placed a button in between the picture opening and closing tag. So button is now going to be my props.children. And so what's going to be rendered on the screen is the image. The image, if I might go back to, is whatever is here. The image followed by buttons. I've got another consumer, and it wants to put an unordered list as within the picture. So this is what we get for the component over here. Another consumer might have some custom components that you have developed, or any kind of complex component that you've developed, and we want that rendered with the image. So all of this is possible because of that props.children property that is always available to us. And the way we use it is, as I'm showing you on the left there. Now, to relate this back to the pattern, the picture, if you like, is kind of the container, and we are composing, because I said React favors composition over inheritance. We are composing different elements with picture. Here, and on the top right, we're composing a button with an image, then a list with an image, and thirdly, we're composing a complex component with the image. So picture is composed, blah, blah, blah. You can read that yourselves. And this is essentially an example of the container. The container in this case is picture, as I said. That's the container pattern. Second pattern I mentioned is the render props pattern. And it turns out now that both this pattern and the container pattern, and even the higher order components pattern that I probably won't cover, they all have the same general objective. And it really depends on the particular scenario that you find yourself in as to whether you use one or the other. By having the same general objective, I mean, they're all about this idea of being able to share logic between components. Like in the picture case, we are reusing the picture component for different scenarios. Remember, reusability was one of our high-level objectives. That's what the container pattern is all about. And the render props pattern has the exact same objective. It's about reusing a piece of logic, which in our case is a component, for different scenarios. What's a render prop? Well, a render prop is a prop. We know what a prop is. A prop is something that you pass to a component. By convention, the prop is called render, but that's only coincidental. It's what render is, what the prop is what's significant. And in the sentence here, I'm saying that the prop, it's a function, but the function, when it's invoked, returns JSX. We've already seen that you can pass functions as props, but that was usually due to that data down, action up idea. But in this case, in the render props pattern case, the function that you pass down as a prop, when it's invoked, it returns JSX, and that JSX then is just inserted into the overall component that received the prop. It's the overall output, if you like. Again, in an example, here's our 101 example. I've got this component called shared component. It receives props as normal. Here's its rendered output, and in the middle of its JSX, I'm going props.render, but I'm using render as a function because I'm invoking it here. And so whatever this function returns, that's what's going to be inserted into this overall JSX. It's very like the container idea, admittedly, but has slightly different applications. Here's a consumer for my shared component. And the consumer, what does it do? It's using the shared component. And for the render prop, you can see here I'm assigning it a function using the arrow syntax, and it's the shorthand version of the arrow syntax. So my render prop function, it looks like it just returns a span. That means that when this component mounts, if you like, onto the DOM, what will actually be put on the DOM is this. The div is coming from up here, and the span is coming from essentially here. Or put it another way, the span is being generated by this expression here. That's the 101 example of the render prop. And what does the text say? The shared component receives its render logic from the consumer. Yeah, same kind of language, if you like, where say hello is the consumer on the bottom left. And as I've already kind of said, or maybe I didn't, the name of the prop is only arbitrary. It's conventional to call it render, because anybody that's reading this code now, when they see render here, immediately they probably will think, oh, this is the render props pattern that's being used in this code. So that was the idea of naming patterns, so that it facilitates communication. Here's a slightly better and more involved example. Don't know if I'm going to get through it now, though. So it's back to our filtered friends application that we had last week. But let's supposing I want to render a friend slightly differently. Two different types of renderings of friend. One is where a friend is rendered by their name followed by an image of the friend, whereas on the right, it's their name followed by their email address. But apart from that, the rest of the application, or these two pages in the application, or these two views, have a lot in common. So there's clearly an opportunity to reuse the code between these two views. We're going to need a component that renders a friend like this. We're going to need a component that renders a friend like this. But the component, let's say, that renders the list of friends, that can be the same for both of these views, clearly. You might remember this is the design that we had from last week. Here's my friend component down here. Now, when I talked about this application last week, there was only one way that I could render a friend. And what I'm saying on the image on the left here is that back then, last week, the relationship between filtered friends list and friend was a static relationship. And that was reflected in the code. If we actually looked at the code for this component here, at the very top, it had a static import of the component corresponding to how a friend was rendered. It's static, right? It can't be changed outside of changing the code. It's not dynamic. So on the right, in order to achieve what we saw on the previous slide, I need to change. I can live with this overall high-level architecture. That's still okay. But what we need to change is we need to make the way friend is rendered dynamic as opposed to static. And the way we're going to do it is this component here is going to pass as a render prop down to this one. It's going to tell it how it should render a friend. It's going to specify the particular type of friend component that it should use in order to generate the list of friends. And it'll do that using, or we will do that using the render prop pattern. Here's excerpts from the code. Now, the one in the middle is the implementation. Is it? Yeah. The code in the middle is the implementation of my filtered friends list component. That's this one here. And you remember from last week, what that receives as a prop was an array of friend objects. So that's still the case. It receives an array of friend objects. And we are mapping over the array of friend objects as last week. But it receives a second prop in this new design. And you can see here that I'm going props.render. So a function, a render prop must somehow be passed into this component. And I'm showing you an example of it being used up here. So here I am using the filtered friends list. I'm passing in my array of users as before, and I'm also passing a render prop. And what does my render prop do? It's a function that returns JSX. In my case, it just returns the way, it returns the component that's going to render a friend in a particular way. Now, you can kind of gather from the name, hopefully, that friend image, the way I implemented that component must be such that it renders a friend's name followed by their image. Whereas down here, I've got another invocation of the filtered friends list. But in this case, the render prop, the actual function associated with it, returns a component of type friend contact. And in my case, the friend contact component renders a friend as their name followed by their email address. So I've got two invocations of filtered friends list. I'm using the exact same filtered friends implementation in both cases, but because I'm passing a render prop into this component, that means that the array of friends that it generates through the mapping here, this, in other words, this array here is going to be different in the two cases. In one case, this is going to be an array of components of this type. And in the case down here, it's going to be an array of components of this type. So this component here is dynamic. It's dynamically computing the types of entries in this array. And the dynamics is controlled by the render prop that's passed to it. Yeah, a lot going on there, I think. So for difference list, blah, blah, blah. Okay, I kind of said all of that. Now, we are getting late, but all I'll do is to point you in the direction of the code that implements this. So this is the archive that you've downloaded. This third folder in the archive contains the code. And if I might be so bold as to just try and hold you for another few minutes. I'll just do npm start and maybe I'll talk through it the next day. Okay, I've got two tabs here, right? If I click on this tab, it renders the list of friends like this. Whereas if I click on this tab, it renders them like this. And it's too late now in the evening to drill into the code. Although you should try and poke around the code yourself to see if you can make sense. The real action is happening in app.js. That's the component that is using filtered friends list. Filtered friends list, you see it's being used here, and it's being used. Oh yeah, yeah. No, I'll maybe I'll just talk through it a little bit at the beginning of the next lecture on Monday with you. Okay, we'll leave it at that for now, if you're still there, and I'll talk to some of you tomorrow and the rest of you on Friday. All right.
Thank you.
Bye.